G'day, I'm Ray Tomes from New Zealand. Welcome to another Saturday Science Summary, a program about cycles and how they manifest in various things. This week's topic is the 160-minute solar cycle. Is it real? It was first discovered in the 1970s, late 70s, and reported by Russian astronomers. And particularly Kotov mentions 160 cycles in many things and made a great study of that area. We'll come back to some more of that. And then it was decided that it wasn't real because 160 minutes is exactly a ninth of a day, and the cycle appeared to be exactly 160 minutes. So some people thought it must be something to do with the Earth. Maybe as the Earth rotates, a little bit more heat on one side and the Earth's doing a little bit of a wobble itself, because the speed they're talking about, it was the surface of the sun moving up and down at a couple of meters per second. Very small thing when you consider there's all this boiling gas there. So the conventional wisdom became that it doesn't exist anymore. And I'll read you a piece out of Wikipedia. The 160-minute solar cycle was an apparent periodic oscillation in the solar surface, which was observed in a number of early sets of data collected for helioseismology. We'll come back to what that means. The presence of a 160-minute cycle in the Sun is not substantiated by contemporary solar observations, and the historical signal is considered by mainstream scientists to occur as a redistribution of power from the diurnal cycle, that's the daily cycle, as a result of the observation window and atmospheric extinction. Now, that's what people are putting in Wikipedia now. I'd like to say Wikipedia is an excellent source for most things, but sometimes they get it wrong, and I'm going to argue that they've got this wrong, that there is more to 160-minute oscillation in the Sun than that. There might be only tiny movements on the surface of the Sun, which happened over a 160-minute interval, but I'm going to show you something where something far more dramatic happens. This is a solar X-ray flux as measured by the, I don't know how you pronounce it, GOES 10, which is data collected by NOAA. And this shows 8.444 days of the fluctuations in the X-rays from the Sun. Now, the left-hand scale there is a log scale, and what that means is every time you go up 1 unit, which is 2 of those divisions there, the amplitude of the X-rays is 10 times as great. So between the lowest lows and the highest highs there, we're talking about 30 times higher flux. And we'll see that there's 2 patches there that I've marked with little red marks at regular 160-minute intervals. And in the first one, you'll see there's quite a lot of them fall on those marks, and some of them miss a little bit. But you see that what's happening there is the flux X-rays is going up by a factor of 10 in the space of a few minutes, and then back down again, and then waits, and then another burst. So these are solar flares happening there. On the lower right, there's another one. It's not for quite such a long period, but the accuracy of them is. There's an expansion of that lower right from the other one. The red marks are at 160-minute intervals. The rises in these X-ray bursts are ranging from 60% to 6,000% in a matter of a few minutes. So the X-rays suddenly turn on and just a great burst of them comes through. And you can see there, they fit pretty well to the intervals of 160 minutes. And this is something that's really definitely happening, solid evidence of that. There are other things in which 160-minute intervals happen in the solar system also. Many of the planets rotate in periods which are 160 minutes times n squared, where n is a small number. In the case of Earth and Mars, they both rotate in 9 times 160 minutes. We already mentioned that was the case and was a possible source of confusion. Jupiter and Saturn rotate in 4 times 160 minutes. So some of the other planets rotate in multiples of 6.4 days, and the sun's included in that. And again, it's n squared. It's 2 squared times 6.4 days for the sun, 1 times it for Pluto, and for Mercury and Venus, it's 3 squared and 6 squared times 6.4 days. So we don't know why they do that, but it's a clear thing, which I worked out. I don't know if anyone else has been aware of that. Kotov was certainly aware of a lot of other things to do with 160 minutes. For example, if you make a standing wave from the centre of the sun, it gives you, of 160 minutes oscillation, it gives you the position of all the outer planets quite accurately. 160-minute oscillations are found in the cores of galaxies. Black holes have radiuses that are either multiples or fractions of 160 minutes, light minutes. Binary stars tend to revolve around each other in multiples or fractions of 160 minutes. A lot of other things Kotov has found. So 160 minutes, in my view, is a wave that pervades the universe. And so I'm not the least surprised that the X-rays show this. I am surprised that mainstream astronomers have given up on the idea that the sun has an oscillation of that period. If we put something in orbit around any of the planets or around the sun, we find a related one, an 80-minute cycle, or just over 80 minutes, half the 160 minutes. The Earth, if we put something in orbit just above the surface of the Earth, which is tricky because that would be in the atmosphere, it'll take just over 80 minutes to go around. And for the other planets, it's similar values, or 160 minutes or 240 minutes, multiples of 80 minutes. For the Sun, if we put something in orbit just above the surface, it will take just over 160 minutes to go around. So I think that there's definitely things going on in the Sun in relationship to that. There will be forces there acting on things. So it wouldn't surprise me if the Sun has that period in the things that were measured. What they were originally measuring was the level of the surface moving up and down. And what they were looking for is over the whole disk of the Sun, they record these movements, and it does like a checkerboard pattern of ups and downs. So one going up while another's going down, and then like this. And it does this over a whole checkerboard of longitude and latitude. And these are called the 5-minute oscillations. They're now called, I think it's G modes. So those are interesting, and it was as a byproduct of this that they found this 160-minute oscillation to start with. So some of the evidence that this is a real oscillation, astronomers in Russia and America and others working in Antarctica did measurements of this 160-minute oscillation in the Sun, and they established that the actual period is 160.010 minutes, so ever so slightly different to a ninth of a day, which means that it varies gradually as time goes by. The phase is gradually shifting from the being exactly a constant place. Not only that, the different places measured the same phase. When they plotted them on a graph, they were all on the same line, showing that this is indeed a real thing that's happening out there. In the case of Antarctica, the big advantage is that the measurements can be done for multiple days at a time because the sun's above the horizon for long periods. So they could do 5 continuous days of observations of this. Whereas in countries that are not in the Arctic Circle, Antarctic Circle, you can only observe the sun for 12 hours or so per day. So I think that, so in my view, it's real. This 160-minute oscillation is real. These phase constancies are one reason to believe it. Other reasons are all the other things that Kotov found that fitted in with that oscillation and other things. The cores of galaxies show 160-minute oscillations or multiples or fractions thereof, and the black holes, the radius of black holes fit into that. So there are many other places where 160 minutes shows up, and in my view, it's one of the fundamental pulsations that's flowing through the whole universe. There are many others, but this is one of the important ones in that time range. So I'm going to say there is doubt. We can always have, in science, we should always have some doubt about things. If there's questions and people raise valid arguments, we need to look at both sides. And we don't have to say, this is the conclusion of scientists, that it's this way or it's that way. It happens all the time that people want to say, scientists all agree that the Earth's warming is caused by humans or whatever. They don't actually all agree, and they don't have to. There should always be an element of doubt about things, and new evidence should be looked at and see how things turn out at all times. We should keep an eye on things and not make up our minds about one thing or another. Science should not be a religion. It should be a continuous inquiry and continually to improve our understanding of the world. So I'm going to say that although a lot of scientists don't believe the 160-minute cycle in the sun is real, they haven't looked at all the evidence, and I think the evidence for X-rays bursts coming at 160 minutes, it's overwhelming evidence that it happens. You can find it. You just got to look at the data. So even if the surface of the sun isn't going up and down a tiny little bit like that, other things are happening, and so I see it would be very surprising if it wasn't going up and down a little bit like that. Okay, so this time, and not a definite conclusion, but you can see which side I'm on. So I hope you've enjoyed this, and not coming to a 100% definite conclusion for a change. Well, hopefully we'll see you again in another one of these episodes. See ya.